Good evening, everyone. I am Debbie Maurice A. Tubo. Allow me to continue the discussion on CVP analysis. Our learning objectives will cover three aspects. First, on target profit. Second, using a cost volume profit chart and a profit volume chart to determine the break-even point and sales necessary to achieve a target profit. And three, compute the break-even point for a company selling more than one product, the operating leverage, and the margin of safety. Target profit. At the break-even point, sales and costs are exactly equal. However, the goal of most companies is to make a profit. By modifying the break-even equation, the sales required to earn a target or desired amount of profit may be computed. For this purpose, target profit is added to the break-even equation. By doing this, the sales unit is expected to cover all the variable and fixed costs while earning the target profit. Basically, in here, we are answering the question of how many units should I sell to gain the target profit. In the example provided, we can think of the target profit as a fixed cost and compute it in the same way we do for the break-even point. In this case, by selling 10,000 units, we will cover all the variable and fixed costs while earning 100,000. Therefore, these are the minimum units we need to sell to hit the target profit. Cost volume profit and profit volume chart. We are using the same formula we previously learned for the computation of the CVP analysis, but to understand them better, we will be graphing them. The cost volume profit, or the break-even chart, graphically shows the sales, costs, and the related profit or loss for various levels of units sold. It assists in understanding the relationship between sales, costs, and the operating profit or loss. So how to do it? We assess the data and compute them in the same way we do for our CBP analysis. Check the data provided in the screen and do follow along with me. Total fixed cost is $100,000. The maximum capacity is 10,000 units, with selling price at $50, variable cost at $30, with a unit contribution margin of 20. We need to answer these four queries before we continue. Relevant range. The relevant range is at 10,000 units, which is the maximum capacity. The selling price is 50, meaning if all those units will be sold, we can have a revenue of 500,000. The variable cost is at 30, meaning the maximum variable cost will be 300,000 plus a fixed cost of 100,000, so our total cost is at 400,000. The fixed cost is 100,000, which is also our minimum loss in case we will not operate. And the break-even point is a fixed cost divided by contribution margin times the selling price. So we have to sell at least 5,000 units for 250,000 pesos or dollars to at least cover all the fixed and variable costs incurred. When making the graph, the horizontal pertains to the units, while the vertical pertains to the amount or value. Then we graphed our cost. We will start at the minimum loss of 100,000 at 0 units sold to a maximum cost of 400,000 at 10,000 units sold. The maximum cost is composed of the maximum variable cost when all items are sold and the fixed cost. Second, we will plot the sales. We will have 0 as our starting line since we do not have any revenue if we can't sell anything, to the maximum sales of $500,000 at 10,000 units sold. Then we can determine the break-even point, which is at $250,000 by selling 5,000 units. The break-even point is represented with a broken line in the graph. All the data to the right from the break-even points pertain to gain, while from the break-even point to the left pertain to the operating loss area. Meaning, if we will sell more units from the break-even point, we will have an income. and we will incur a loss if we will sell less than the break-even point. The profit volume chart plots only the difference between total sales and total cost of profit. In this way, the profit volume chart allows manager to determine the operating profit or the loss for various levels of units sold. In making the graph, it is the same scenario for the profit volume charts. Although, instead of looking at the cost, sales, and volume, we are focused on the profit. As a continuation of the previous problem, the relevant range is the same. If all the units produced are sold less the variable and fixed costs, we will have a $100,000 gain. Of course, the minimum loss will be at the fixed cost in the event we can't sell anything, and the break-even point is zero income or loss by selling 5,000 units. From that data, we can connect the dots. It operates on the same logic. The units will occupy the horizontal line, while the value, in this case the operating profit and loss, is on the vertical side. First, let's plot the minimum loss to the maximum profit. We will have a diagonal line starting at 100,000 loss at 0 units sold to 100,000 gain at 10,000 units sold. We shall graph the break-even point in which we will have no income or loss by selling 5,000 units. From the break-even point to the right pertains to gain, while to the left is the operating loss. The effect of changes in the unit selling price, the total fixed cost, the unit variable cost on profit can be analyzed using a profit volume chart. Such movement will have an impact on profit and so the break-even point. In such case, the graph will have to move to represent such changes. There are assumptions made of cost volume profit analysis. The primary assumptions are as follows. Total sales and total cost can be represented by a straight lines. Within the relevant range of operating activity, the efficiency of the operation does not change. The cost can be divided into fixed and variable components. The sales mix is constant. There is no change in the inventory quantities during the period. These assumptions simplify cost volume profit analysis. Because they are often valid for a relevant range of operations, cost volume profit analysis is useful for decision making. Next, let us continue our discussion with the sales mix, operating leverage, and the margin of safety. CVP analysis can be used with single and multiple products as well. Many companies sell more than one product at different selling price. In addition, the products normally have different unit variable cost and thus different unit contribution margins. In such case, break-even analysis can still be performed by considering the sales mix. The sales mix is the relative distribution of sales among products sold by the company. Let's study the data provided. There are two products sold, A at 8,000 and B at 2,000 units. From this, the sales mix can be computed at 80% for A and 20% for B. From that, we will make a third product. Let's call it product E. The selling price and variable cost for third product are based on the sales mix made by A and B. Using the contribution margin, which is 25, we would know that we need to sell 8,000 units to break even. To show that such is indeed the case, we will be selling 8,000 units. A will sell 6,400 and B 1,600 using the 80-20% sales mix. Using the regular computation for the contribution margin, we will see that by selling such mix, we will attain a break-even point. Remember that one of the assumptions made in CVP analysis is that sales mix is constant. Let's go to operating leverage. The relationship between a company's contribution margin and income from operations is measured by operating leverage. The difference between contribution margin and income from operation is fixed cost. Thus, companies with high fixed costs will normally have high operating leverage. Given that Jones has a higher fixed cost, it's expected that he will have higher leverage than Wilson. So, what is the use of the operating leverage? Operating leverage can be used to measure the impact of changes in sales on income from operation. Using operating leverage, the effect of changes in sales on income from operations can be calculated. To illustrate, assume that sales increased by 10%, both for Jones and Wilson. So from the old income of 20,000, Jones will have a 30,000 income and Wilson will increase from 50,000 to 60,000. So to illustrate that that is indeed true, let us recompute. From here, we can prove that indeed, with a 10% increase in sales at 50% and 20% operating leverage, we can identify how much its impact on our income. From our illustration, we can also prove that high operating leverage will have large impact on change in sales, and low operating leverage will have a small impact on changes in sales. This is due to the fixed cost component that has a huge impact on its analysis. Let's go to the margin of safety. The margin of safety indicates the possible decrease in sales that may occur before an operating loss results. Thus, if the margin of safety is low, even a small decline in sales revenue may result in an operating loss. A margin of safety can be expressed in three ways: dollars of sales, unit of sales, and percentage of current sales. From the data provided on your screen, let's compute the margin of safety. Given that the sales are at $250,000 and the sales at the break-even point are at $200,000, the margin of safety from our current sale is at $50,000. Given that $50,000 is the margin of safety, how many units must we sell? So it will be computed by dividing the margin of safety in dollars by its selling price. Then, to get the margin of safety in percentage, we simply divide the margin of safety in dollars by the sales. The margin of safety can sometimes be seen as the same computation of the break-even point. However, they are different. The break-even point is the sales volume at which the entity covers all its costs. In example, it earns no profit and incurs no loss. The margin of safety is a percentage by which the entity's actual or estimated sales volume exceeds the break-even point sales volume. Thank you for listening. For the supplementary analysis in the usage of CVP analysis, let us proceed to our sample case.